Welcome to another brief video of me kind of just talking for a while. This one's going to be talking about observational studies or like sample surveys, those are synonymous, versus experiments. I guess they're not synonymous, but they're similar. A school offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1220. The average SAT score for all students who did not take the prep class was 1050. Observational study or experiment? Well, the researchers in this case did something, right? So they weren't just watching, they weren't just asking a question. They imposed a treatment, right? They put people through this class. So this actually is going to be an experiment. Now, is it a good experiment? Not really, because there's a bunch of other things that we need to hit in order to make a good experiment, but this is an experiment. So that's the main difference. Observational studies, they don't impose a treatment, right? They just collect data. They could be asking questions. They could be sitting at a traffic light and watching what people do at a yellow light, like that. They're just observing. Experiments, though, impose some treatment on members of the study, and imposing that treatment is what allows us to get causation. Doing an experiment lets us finally say this caused this. Now, there's some other thoughts to it still, like it caused it maybe just in this group. I don't know if it causes it for everyone, but we can talk about that later. Okay, so this is the same setup. What's the explanatory variable and what's the response variable? Our explanatory variable is, I guess I'd call it SAT prep course status. And it's whether they're in the course or whether they're not, right? The values it takes on. Are took course and didn't take course. And then our response variable is, that's just their SAT score. Ta-da! Does taking the prep class lead to higher test scores? Why or why not? I don't think I could say that, at least not the way they did it, right? And here's part of it. Students can volunteer to take it. Who's signing up for an SAT prep class? Generally, it's people that are already motivated. I can't say that this caused this in this case. This is kind of an experiment, but it's not a very good one because we're missing a key feature, and we're going to get to that in a couple slides, I believe. We need randomly assigned, not randomly assigned. Right, that's the issue here. We had volunteers. What are the other variables that could be influencing SAT scores? That's what I just said before. Motivation. People that are highly motivated are signing up for the class, but they might already be doing stuff that's been improving their scores. If we don't impose some treatment randomly, we can't draw conclusions, right? We can't get that this caused this. This is because there may be confounding variables. For us, a confounding variable was motivation, right? Their motivation affected whether or not they would enroll in the class, but their motivation also probably affected their score. So we thought that it was course tells me what the score does, right? But if motivation is increasing course participation and increasing score, well, there's this other variable that maybe that's the only real reason, right? That's what a confounding variable. It's a variable that has not been controlled for that can affect both your response and explanatory variables. Okay, I'm going to go on because you can pause. Explanatory variables are what we use to predict outcomes, just like in bivariate data when we were talking about that before. If you have more than one explanatory variable, we call them factors. Factors can have multiple values or multiple, yeah, they're called levels. Levels are the values used for the factors. And the way I always try to remember this, excuse me, is through baking cookies, right? So things that you might that might affect how a cookie turns out is the cook time and the temperature, right? So those are my two factors because those are explanatory variables. They're explaining how the cookie would turn out, and there's two of them, so those are my factors. Now, for cook time, you could have 9 minutes, 12 minutes, and 14 minutes. Those are the levels of cook time. And then for temperature, you'd have 375, 400, and 425. Those are the levels for temperature. Now that we have factors and levels, treatments are actually what's done to an experiment. It's all the combinations. All right, each individual receives a combination of factors. All right, and the last thing, the participants in an experiment are called experimental units. Often when they're humans, we call them subjects. So very, very, very vocab heavy in this lesson. Okay, bye.